Aurélie Clédic from LAS, and I will present you our contribution first step for designing adaptable user interfaces to mediate human-robot interaction. So there is a wide diversity of platforms for teleoperating robots that are declining in multiple versions, and this diversity is partly due to the numerous types of robots. If we look, for example, to the robotic platforms we have at LAS, we have drone, humanoid, quadrupeds, ground robot, and besides this diversity of platforms, there is also diversity of users and use cases. So every robot use case and type of user brings a unique set of expectations. So we propose that human-robot interaction should consider the opportunity to use an external device, such as a smartphone, to not only teleoperate, but also mediate the interaction with the robot, either in telepresence or in co-presence. So indeed, with smartphones and tablets, we already possess very powerful devices with performant hardware, good microphone and speakers. So while interaction between humans and robots through speech and gesture is not yet done, speech recognition is today impressive on mainstream devices. And moreover, the feedback of the robots through this device could also prevent issues, for example, regarding the presence of noise and etc. And also allow easy adaptation on the user side. They have also good camera, good quality image recognition could enable, for example, gesture recognition. Moreover, it could be possible for the user to take a picture of an object or a person to provide information about that object or person to the robot, or ask questions about the content of an image. We have also high quality displays with infinite possibilities in graphical interface design. So the video stream and other information perceived by the robot can easily be displayed, as well as a graphical user interface that enables interaction between the user and the robot. We have also a display with touch capabilities, so touch interaction is natural to today's users. So an interface using buttons and other standard widgets is an obvious choice, but also richer interaction can be imagined. So for instance, from the recognition result of the robot displayed on the device, we can imagine that the user simply clicks on a detected object to ask the robot to pick it. And we can also have access to user data, preferences, and profile. And last but not least, the way to use such device is common knowledge for a large amount of the population. So in front of the growing variety of robot design, it could help to tackle the heterogeneity in existing interfaces to enable a human-robot interaction. Moreover, besides the possibility to mediate the interaction, this device could help to frame it. So for example, we can imagine to display on the device the robot's abilities and limits, how it could be used, etc. So it could help to enable what we call mutual recognition between the user and the robot. So our approach is to design a modular interface that adapts to these diverse factors, applying user-centered design method. And we take the opportunity to test it in our lab with our robots. So we opted to apply user-centered design and participatory design methods. So as part of the need analysis and design stages, we organized 2 brainstorming sessions. The first brainstorming included permanent member of the robotics lab, and the second one included PhD students. At the start of each session, participants were briefed on the objective to generate ideas for a teleoperation interface for robots, and participants were asked to suggest at least 3 ideas, writing each one on a post-it. And these instructions were for the robot you use and the use case you are familiar with. You are invited to design an interface on a tablet with a joystick optionally. What would your ideal interface look like? Consider aspects such as information display and placement, possible commands, and how to manipulate them. So from the first brainstorming, so we get a lot of post-it, and from the first brainstorming, we get the following results. So that can be classified in 6 categories: vision and detection. So people asked for image acquisition by the robot, identification of people, of obstacles, linked to the robot knowledge base. We've got also information about status of robot actions, past, present, and futures. So, for example, explanation of the robot's intention, visualization of the robot future, trajectory of robot expectation, etc. Information about mapping, map for navigation and localization, contextual information such as integration of weather data, date or time, system status, monitoring of the battery, error, etc., and communication. And from the second brainstorming, we get, in fact, the kind of same categories plus new categories such as user information, so monitoring physiological indicators such as brain activity or heart rate, robot usage, tracking data related to the robot's usage, such as the last person who used it, trust, so assessing the robot's trust in the user, evaluating the robot's confidence in its ability to perform specific tasks, motivation, user interface, so implementing tools for the interface, and documentation, so accessibility of the documentation associated with the robot. So these two brainstorming allow us to understand our users and their needs. So there were common category differences, but also psychological aspects. So from that, we had a design and prototyping phase with, for example, paper prototypes. We also considered the accessibility of the platform. We paid attention to the sizes of the button and the interactive elements. We consider also colors and contrast. And since we had, for example, colorblind people in the team, we added patterns to the colors. So at the end, we have for now 3 interface prototypes, one for naive users, enabling, for example, to pilot the robot in the environment, one for a presenter mode that was asked for people conducting a demonstration at the lab, and one for a developer mode, giving information, for example, for debugging. So in this study, we explored the potential of leveraging external devices such as smartphones and tablets to enhance human-robot interaction. And while this work is only an initial step, it demonstrates the interest in interacting and communicating with a robot via an external device also and as a media of interaction. And of course, future development will be necessary. However, the current setup is highly customizable and adaptable, making it feasible to deploy soon across multiple robots in our lab. So we have it for now on 2 robots. And we have a follow-up project to use telepresence robot for hospitalized children, where we plan to use the same setup. Thank you for your attention.
Thank you, Aurélie. Have any questions for Aurélie? I have one question for you, Aurélie. You mentioned your participants were PhD students and postdocs. And in your last slide, you talked about children. Do you think some of the insights that you obtained are transferable across cultures, across genders, across age, or do you think these things have to be adapted?
So, yes, so in fact, the first ask was from this project about robot use in hospitals. So it's a very interesting setup because they use telepresence robots for hospitalized children. So the children is at the hospital and the robot is a children's home. And they ask us about the fact that their interface, there were no joystick and so on. So they ask us to help them to improve the system. And since at first we didn't have access to the children, we choose to try to see what the use of a media of interaction could mean also for any robot. So that's why we have this first setup at the lab. But we think, yes, that there are common stuff. Like really, the idea is to develop the idea that to communicate with the robot, the use of a media that we know how to use, such as our smartphone, could be very useful and could really help the interaction.
Great. Thank you. Any other questions? If not, let's thank our speaker again. Thank you, Ellie.
Thank you.